So that will be your problem number 9 instead. So for this one, you have this rocket projected from ground level. So here it is from ground level. But it's done to 2 different trials. So that would be your trial 1, and that would be your trial 2. So projected. So this is shot with a velocity v1, and this is with a velocity v2, because those two velocities are different. And this one requires a time t during which the rocket is in the air, and this one instead stay in the air for a time 2t. So they want to know the difference between those two maximum, between the two maximum heights. So this one will reach a height y1, and this one will reach a height y2. So according to this trial, you have a y1, so it starts in front of the ground. So let's say that y is equal to 0 here at time 0. y0 equals 0. So y1 is equal to y0 plus v1t minus 1/2 gt squared, with this one as a 0, right? And this one has a y2 equal to the y0 plus the v2t and minus 1/2 gt squared. But the t is reality. Reality is 2t, so 2t is also this one, right? So at that point, we got to find a way to express basically v1 as a function of v2 or vice versa, and solve for one of those two equations. So for example, for this one, we know that v1, right, will be the same as negative gt. And because those are maximum heights, right? So when you have a maximum height, this means that you go up here and then you come back. So up here, your velocity is 0, right? Same thing for this one, right? Velocity is 0 up here. So basically, this means that you got to go through the equation for either one of those, v equal to v0 minus gt. Now this is the final, this is the initial. The final velocities for those scenarios, for this one and this one, being the v maximum, the maximum height, the velocity at the maximum height. Right here, velocity is 0 because the rocket was going all the way up, reaches the max and comes down. So here you got to have an inversion of velocities from positive to negative, so it necessarily has to go to the 0 value, right? So from here, then you have the v, we call this one just v, so v is equal to is equal to gt, right? Now for this one, so the v1 is equal to minus gt, because if I consider this one as the initial velocity, it has to be positive, right? But so v0 is this one, which is up for both cases, so this is positive, but the gt is negative, so this means that v0, right, is equal to gt, positive. So v1, right, is in reality the initial velocity is equal to gt. That's just a plus, right? We can remove it so it doesn't confuse you. So gt, and in this case instead v2 is equal to g, but the time is going to be 2t, is not just t. So from here you can see that this is the same as 2gt, which means if gt is v1 is equal to 2i's v1. So now we have a relationship between the v2, right, and the v1, and we can plug it, for example, everything in here and see how those are related. So y1, y2, I'm sorry, so this is 0, is equal to v2, okay, but if I'm using v2 as a 2v1, well, I can do that anyway. So this is twice v1, where v1 is this, right? So gt, and then minus, oh, I'm sorry, so 2v1, so 2v1, which is gt, right, times 2t. Okay, so b2, instead of b2 I write this one 2, but b1 is the same as gt, and then I got to still write the 2t. So 2 gt, which is b1, times 2t minus 1/2 g, and then this is 4t squared. So let's keep going. So y2 is equal to, so I can do 2 and 2 is 4, right? gt squared minus 1/2, but I can do this, right? So minus 2 gt squared. So this is the same as 2 gt squared. Now let's find out how is y2 related to, which is equal to this, related to y1. So if y1 is 1/2 gt squared, how many times this is smaller than this? Well, if I multiply everything by 4 here, right, I will have the same number as this one. So y2 is 4 times, right, 1/2 gt squared, right, which is the same as 2 gt squared, which is this, right, but is the same as 4 times 1/2, which means it's 4 times y1. So that's why the answer is B, because the maximum height in the second trial, which is the y2, is 4 times the one for the first trial. So that would be your question number 9. Number 10, you have a particle moves along the x-axis with acceleration this. So this is the acceleration 6t. We know that from A to B we move by integrating A in dt, which is equal to, A is equal to 6t, so 6t dt. 6 goes out of the integral outside, so this is just a t dt. This is 6, and then the integral of t is 1/2 t squared plus the constant. Now, keep in mind those constraints that the problem is giving us. So t equals 0, time is 0. At x instant 0 is 0, velocity initial is 0. So even if you have the constant there, which you do because it's part of the integral, you still don't have any value to write because it's a 0 there. So 6 divided by 2 is 3. 3t squared is your final answer according to the expression. But then what in reality is b at 2 seconds. Well, you got to substitute 2. You have to substitute 2 in the expression there. So you have 3, 2 squared. So 2 squared is 4 times 3 is 12 meters per second, which is your answer for question number 10. Number 11, you have a particle moves along the x-axis and the acceleration is still a equals 6t. And a is in meter per second squared, t is in second, same constraint as before. Where is the particle? So we solved for t, which was the 6 t dt, but not only this is an answer, so this is actually 6 and 1/2, like we just said before, t squared, so this is the 3t squared, right, plus the v at time 0. For the position instead, you got to integrate the v dt. True? So you got to have a 3t squared plus v0. Everything is done in dt, and that's the integral of it. So you can write the addition of two integrals is the same as the integral with the addition of those two functions. So we can have 3t squared dt plus v0, and this is just the dt. And this is the same as 3 over 3t cubed plus the y0, the x0, and you have the constant there, right, v0 t. Okay, so so this is 1. Now go back to your constraint. The constraint from before say that x at time 0 is 0, b at time 0 is 0. So just because of that, those two values are zeros, okay? So your final expression is t to the cube, which means that at time 2, so which means that x at 2 seconds is equal to 2 cube meters, which is equal to 8 meters. And problem number 12. Yeah. So an object starts from rest. So this means y is v0 equal to 0 at time t equals 0. And t0 equals 0. Velocity v as a function of time is given by, so v of t is equal to 2t plus 3t squared. How far? After 5 seconds, so x of 5 is what we are looking for. So x of t, according to the expression, is equal to the integral v of t dt. So this means that this is the integral of 2t plus 3t squared in dt. So this means 2t dt plus 3t squared dt. And just solve those integrals. So 2 times, this is 1/2 t squared plus 3 over 3 t cubed plus the constant, which is x0, right? So those go away, So this value here we can assume is 0 because we want to know the distance traveled in 5 seconds. So wherever this initial position is, we got to add this amount here. I mean, what they are asking in reality is x of 5 minus x of 0. So it's just the interval that they are looking for, not the effective positions. So this one we can assume is 0. So at that point, so we wanted at time 5. So this is 5 squared plus 5 cubed, and this is equal to 150 meters. Then number 13, an object is moving in a straight line and has a velocity of, so let's go here, v equal to 8 plus 2.5 is the same as 5 over 2, right? T squared. And they want to know the acceleration instantaneous. So every single time we are dealing with instantaneous stuff, we got to write down the function. So a, the acceleration is dv in dt, which means 8 derivative of 8, right? So let's do this. I don't know if it even makes sense. d8 in dt, I mean, that's just a 0, right? You cannot derive a constant is a 0. So you have 5 over 2, and then this is the 2t, which gives you a 5t. They want to know the acceleration at time 2. So this is 5 times 2, which is the same as 10 meters per second squared. Number 14, displacement between, so they are looking for the x between a delta t of 0 and 6, so for 6 seconds. So to do this, the expression for x is the same as 8 plus 2.5 t squared, which is the one, which is 2.5, which is the expression for velocity, right? But we have to integrate it in dt. So that's the same as 8t between 0 and 6 plus 2.5 over 5 over 3, right? Because this is the 1/3 t cubed between 0 and 6. And then that's the same as 8 times 6 plus 2.5 over 3, 6 to the cube, which is the same as 228 meters. That would be number 14. Number 15 instead. 15 says you have the rocket shot vertically upward in the air with a positive initial velocity. Which of the following correctly describes the velocity and the acceleration of the thing, of the object? So it's shot upward with the air with a positive initial velocity, and at the maximum elevation, what happens? So this is what happens. So that's where the point that we are focusing on. In here, you know very well the velocity has to be 0 because it's the turning point between the positive and the negative. And then you also know that in every single instant, not just here, right, the acceleration is always downward, which is the g and g everywhere. Okay, so your answer D is the right one, where you have 0 velocity and negative acceleration. And then number 16, find velocity at, so you have a acceleration value given, and here you have the acceleration, right, is equal to 8t plus 4. And the object is initially 2 meters from the origin, so you have a position initial which is 2 meters from the origin and moving to the right with a speed of 2 meters per second initially, right? So they want to know velocity at time equal 3. So in order for you to calculate this, first of all, you got to know what dt is, right? So to find the p, you have 2, so you have the acceleration, so you got to go up. So this is your integral at plus 4 everything dt, which means 8 over 2t squared, to go a little faster, 0 and 3, and 4 t between 0 and 3, plus the initial condition, because that's your velocity, you need to have the initial condition. So this will give you 4 times 9 plus 4 times 3 plus the 2 meters per second that they gave us. Okay, and this is going to be your 15 meters per second as initial velocity. Then number 17, they want to know displacement after t. So after 3 seconds, so x of t is equal to 4t squared, right from here, 4t squared plus 4t so the integral of this, right? And you also have plus this, which is the 2, everything in dt. Okay, and this is so 4/3 t cubed plus 4 halves t squared plus 2t plus x 0. So here you have the 4 over 3 t cubed plus 2t squared plus 2t plus x 0, which according to our constraint is 2 meters also. Okay, and they wanted to know at time, that's number 17, number 3 seconds. So that's 4/3 cubed plus 3 squared plus 2 times 3 plus 2. And that is equal to, so this will be 62 meters. Now, let's just analyze what is this. So this is the actual distance traveled, right? Distance. But they are asking for displacement. So displacement is a vector, right? So if we are looking from 0 to the final position, this is number 62. But we know from the constraint that this is x0, which is equal to 2. So that displacement in reality is this, which is 60 meters, which is your answer. And number 18. So an object in free fall has a velocity of 5 meters per second in the upward direction. So 5 meters per second going up. What does free fall mean if it's going up? Well, that means that it's subjected to gravity, right? So the gravity vector is down there. And what is the instantaneous velocity 1 second later? So for instantaneous velocity, if you know that has a velocity of v0 minus gt, right? The v 1 second later is going to be the 5 meters per second upward minus the g times 1 second there. So this is going to be about 10, so negative 5, right, is the meters per second, or you can say also 5 downward. Remember, it's important for us to give us the directions. And then number 19. Number 19 says, at what velocity, vertical velocity, should an object be launched in order to achieve the height of 20 meters? So they want a maximum height of 20 meters. Starts from 0 because they are not stating anything different. So they want the initial velocity. You know that the Vmax at the max positions is going to be 0 because, again, that's what they are saying. What's going to be this velocity, right, if the maximum height is 20. So this means the max velocity up there has to be 0. The velocity, not max velocity, the velocity at the x height, right, maximum height. So you do v final equal to v0 squared, v final squared, v0 squared minus 2gh, right? And just by solving, so you know that this is going to be equal to 0, so v0 is what they were looking for, 2gh square root, right? And this is about, so let's do the about stuff. So 9.8 is about 10, this is 20, right? So this is 400, which means 20 meters per second is the velocity that is required. Number 20. For number 20, how long will it take for an object accelerating at a constant rate of, so that would be your acceleration, 5 meters per second squared, to change velocity from 0 to 6. So from 0 meters per second to v final, I guess, 6 meters per second, or we can say v1, v2, whatever makes you feel better. So v final is equal to v0 plus at. So your t is v final minus v0 divided by va. So 6 minus 0 divided by 5 is 6 over 5, which is 1.2 seconds. Okay. And then this is number 20. And then 21. An object is thrown straight downward on Earth with initial velocity. So that your object is thrown downward with initial velocity, which apparently is negative, right? Equal to 10 meters per second from a position of 20 meters. So that will be your h, 0 meters above the ground. So that's the position. So you're throwing it from here, right? So with initial velocity though. So that would be your initial velocity. And this is your 20 meters. per second. And the speed when it reaches the ground, they want to know. So you have minus v final because it will reach the ground with a negative velocity equal to initial velocity, which is also negative, and minus 2gh. So basically we can consider at this point everything positive, nothing changes. So your final velocity, which is the one that you're inquiring about, is just given by here. So will be your 100 squared, 100 plus 2 times the g times the 20, which is negative 300. But don't forget that this is the negative, right? Oh, but we changed everything for positive, sorry. So this is 300, which means square root, which means this is 22.2 meters per second. And problem 22. Here you have a ball dropped from a height h. So position initially is h without a resistance if the ball falls a distance. So now the y is equal to h over 2 in a time t, so it takes t to do that. How much time is required to fall the remaining h over 2? So for this problem, I would be so interested in knowing actually how you are resolving. So this is the way I'm thinking. Starting from h and goes down h over 2, and to do this takes t. And to do this, it takes a t1. So again, this is what you're looking for. You're looking for t1. So by using the equation y equal to y0 plus b0 t plus 1/2 at squared. So let's see what we have instead. We have a final position because I'm looking between those 2 points, right? Because I know that it takes t time to do this. So to do that, I would say that h over 2 is equal to h, right? H over 2 is the position final, starting from the initial position, which is 0, plus b0t, which is still 0 because that's the constraint we got, minus 1/2 gt squared. Okay? And so by doing this, and if I bring this one, so bringing h to the other side, I will have a minus h plus h over 2 equal to minus 1/2 gt squared, which means this is negative 1/2 of h over 2 equal to negative 1/2 gt squared, which means I can remove the negatives, right? And I can remove the 2's. So from here, I will see that 2h over t, 2h over g square root 2h over g square root is going to be t. And that's the time I know. So let's call this one. Okay, so this is the time. Okay, that one. Now, if I instead focus, right, between 1 and 2, okay, between those 2 positions, I know that the final position, which is 0, is equal to initial position, which is h2, h over 2, right here, between here and here. And then plus, actually minus, because it's a vertical velocity, right? Right here I have a v1, t, 1, minus 1/2 g t1 squared. Okay, now do I know what is v1? Well, I do, because again, considering this track here, right, to go from here to here, I'm going from 0 to V1. So I know that V1 is equal to V0 minus GT, and this is 0. So V1 is equal to, which is negative, also because it's going down, right? So V1 is GT. So from here, I can just substitute and say that 0 is equal to h over 2 minus V1, we said is GT, right? GT times T1 minus 1/2 GT1 squared. Okay, and so let's solve this one a little bit. Let's make it look a little better. For this one, so we can say 0 equal to h minus 2 GT1 minus GT1 squared. So let's organize it with a positive sign there. So this is GT1 squared plus 2GT1 minus h equal to 0. So from here, solving your quadratic, right, equation, this is negative 2GT plus or minus 4G squared T squared plus 4GH over 2G. If you know the simplified one, you can divide everything by 2, but it's your choice. I don't want to confuse and to give you too much. H over G instead of T, because we have calculated, right, that T is equal to this value here. So this is plus or minus square root of 4GH G squared G H over G plus 4GH divided by 2G. And then at this point, this is the same as minus 2, and follow. See, please, how I'm writing everything in the equal signs where they belong and stuff. Do the same, because otherwise your readers for the AP exam, they will not even understand what you're doing. Okay, divided by 2G, and that's the same as minus 2 square root of GH, because I can bring this one in and make it a G squared. The G squared divided by G is just a G, so it's right there. Plus or minus 2, because I can write this one as 2 to the cube, so 1 2 goes out and 1 stays in, GH divided by 2G. Why did I do this? Because you could have done this before when I said you can just divide everything by 2 or whatever. And then equal to, this would be minus, let's bring this G inside. I don't know, I'm playing. So if this one goes inside, it becomes squared. So now this is H over G. And this is also 2H over G, so plus or minus 2H over G. Okay, and I can write this as, so this is T if you remember, so minus T plus or minus square root of 2T, which is the same as T minus 1 plus or minus square root of 2, which will give you a, we only care about a positive number, which is 0.41T, which is the one that you want. So that would be the solution for this whole problem. Okay, and that was 22. For 23, then the following function represents the path taken by an object. So this is x equal to 4t squared minus 3t plus 2, where x is the object's position and t is time. How far does the object travel during the first 3 seconds? So Now pay attention between position at, which means if they were saying position at 0, well, you just do the exit time times 0, so this is 0, 0, that would be 2 meters, right? And then they say, for example, position at 3, then you will just put there the number 4, and then it's a 3 squared minus 3 plus 2, and you will solve this when you find 29 meters. But they say position during the first 3 seconds. So they want a delta x, right? So they want an x final minus x initial. Okay, so they wanted 29 minus 2, which is 27 meters. Okay, and then number 24, the following function represents the path taken. So again, it's the same equation as before. So x equal to, so that's the new problem. X equal to 4t squared minus 3t plus 2x is the object position. How far away from the origin? Well, if they say from the origin, we are not just looking for the delta x, we are looking for the position, okay, in the line, okay. This is 0, this is the position at time 0 when the chronometer starts, for example, when your clock starts, and this is where it stops, and this is your position 29, but from the origin, the position is 29 meters, so that will be your answer. And then so 25, the following function represents, again, the same thing. So x equal to 4t squared minus 3t plus 2, where x is the object position at time t. What is the instantaneous velocity? So first of all, you got to calculate the equation, right? This is x of t, so the velocity has to be 8t minus 3, right? That will be your velocity. And then at time 3, so v of 3 is equal to 8 times 3 minus 3 is going to be 21 meters per second. And then number 26, following function represents the path taken by an object. Again, the same stuff. So same equation as before, I'm not writing it again, so that's the same x. And at what time is the velocity 29 meters per second? So they want velocity equal to 20. So we said velocity has to be, so that's the velocity, so it has to be 29. So that's super easy because you just have to solve for t, right? So 29 plus 3 is 32 equal to 8t, which means t is equal to 4 seconds, and that's it. And number 27, the following function, again the same. What is the instantaneous acceleration? So if that's your velocity, because according to the position that they gave you, you calculate your velocity. So your a of t is going to be the derivative of this, so it's going to be your dv in dt, which is the same as 8, which is a constant, so there's not much to think about. That's your velo acceleration, whatever. And then number 28, the following function represents the path that taken, again, is still the same x. What time is the acceleration 10? Well, the acceleration is always 8, so there's no way it's going to be 10 anywhere. And number 29, the acceleration of a moving object, so that's 29, is a equal to 90 squared plus 2. And at t0, the object, so for t0 equals 0, x0 is negative 2 meters. And is traveling with velocity of, so v0 is equal to 3 meters per second in the negative direction. Okay, so it's traveling that way. Let's say that this is positive, so the other one is going to be negative. How fast is the object moving at t equal 2? So fast, that means we need a v of t because they say at t equal 2. So first of all, we need to integrate this, right? Because we are going up one step. So this is the a in dt. So this means 18. What am I saying? So this is 9 divided by 3t cubed plus 2t, okay, plus the v0, okay. So this is equal to 9 over 3 is 3t squared, 3 cubed, plus 2t minus 3, which is your constraint, right? And then v at 2 seconds is going to be 3 times 8 plus 2 times 2 minus 3, right? So this is going to be 24 plus 4 minus 3 is going to be 25 meters per second. And number 30. Number 30 states the acceleration is still the same, so a equal to 9t squared plus 2, same constraint as before, is traveling as before. That's the acceleration at t equal 3. That's super easy also because acceleration is the same at time 3, so 9 3 squared plus 2, that's 83 meters per second squared. Number 31. The acceleration of moving object is represented by the function again a equal 9t squared plus 2. At t equals 0, x0 is negative 2 and is traveling with a velocity of 3 in the negative direction, same conditions as before. At what time is the acceleration? 38. Well, the acceleration 38 when t is equal to, I don't know, let's solve it, right? So 38 minus 2 divided by 9 square root, right? That's your t. So 36 divided by 9 is 4, square root is 2, right? So 2 seconds is your answer. And then 32. Problem number 32. The acceleration of a moving object is represented by the function again. And the object is negative 2, traveling blah blah. How far from the object is at 2. Okay, so how far? That means we need to find the x of t first of all. That's our answer, that's our quest. And then we got to find x of 2. So let's do that. So this is 9t squared plus 2. Velocity we saw before, right? This is 9/3 t cubed plus 2t plus v0. But then when we go for x of t, we need to have, so this is 3, right? T cubed plus this is 2t minus the position, the velocity we said was plus 0, velocity was 3, so plus 3, but in the negative direction, so that was negative 3. And this is the integral of this that we need in order for us to calculate the displacement, right? So this will give you 3/4 t to the 4 plus 2 say over 2t squared minus 3t plus x0. Okay, now remember the x0 is 0 because that was the constraint given by the problem. So you have a 3/4 of 2 to the 4th plus 2 squared, that's gone, right? Minus 3 times 2, and this is 8 meters. Okay, so let's change page. And your number 33 is going to be the following. So you have the picture there. Let's look for the picture. Is your number 33. Okay, so you have this. A car starting from rest uniformly accelerates in a straight line as shown before. What is the acceleration during the entire 3 seconds interval? So for this one, without doing too much struggle, right, you just see that the total distance traveled is 18 meters. Total time traveled is 3 seconds, right? Initial velocity is 0, so I would just use the famous equation, like we said in class, the first equation. So I will just say that y is equal to, or x in this case, whatever y is 0 plus b is 0t plus 1/2 at squared, right? So final position is 18 according to the graph. Initial position is 0, initial velocity is 0 according to the graph. This is equal to 1/2. They are asking for acceleration. The time is 3 seconds, and you just solve for time, right? So your acceleration is going to be 36 divided by 9 is equal to 4 meters per second squared. And number 34. What is the average velocity of the car during the first 2 seconds? So, average velocity, so all of a sudden, if we don't write dt in dv in dt, we write a delta t. So, this is your delta x over delta t, which is the same as 8, right? In the first 2 seconds, look at your graph, it's just 8 divided by 2, which is still 4 meters per second. So same number but different units, so not necessarily important there. And then number 35. So you have the graph, and so let's go back to the graph. And they say, what was the average velocity of the car during the first 2 seconds? Oh no, that's the one that we answered. So this one, based off this graph, the velocity as a function of time looks like this. For which of the following sections of the graph does the object moves a non-zero constant acceleration? So you know that constant acceleration means velocity is changing with a constant slope. Now here velocity is not changing at all, so there's no acceleration whatsoever. And then here the velocity is changing with a constant slope, so here the acceleration is constant. Here there's no acceleration. Here there's acceleration, deceleration, but is not constant because it's moving according to a slope, because this is a second order function. So you go down to the first order, so it's not a constant. So B is your answer. And then 36. So with those problems, what do? An object is dropped from a height h and it reaches the ground with velocity v. Same object is thrown from the same height, but with a velocity v, not 0. When it reaches the ground, it has a velocity v2, obviously bigger than the other one. Which of the following is correct? Well, I don't necessarily want you to just say it, so you know that v2 has to be bigger. And so you got choices, right? Only C is not right. So how would you proceed? So how would you demonstrate this if that was, for example, your free response problem? So in the case 1, okay, so don't forget those pictures, so keep it in mind. So in scenario 1, okay, so case 1, you have P equal to GT. Okay, or you can say negative V equal to negative GT. But we can remove this negative and put a V equal to GT. And then also you have a 0 equal to, which is the final position, which is the ground, equal to the max acceleration from which the body was thrown, was dropped, minus no velocity because it's dropped from 0 velocity, 1/2 GT squared. Okay, so this one will give us h equal to 1/2 GT squared, which means that 2h over g is equal to t squared. So we can decide if we want to yes or no, take the square root. It depends on if or when we are going to substitute this v. Then your velocity at that point is going to be gt. So yes, let's take the square root of the velocity. So that would be your t, right? And I will substitute right there. So this is g times the t, which is square root of 2h over g. We can do the same tricks as before, so bring this one in. So this is square root of 2gh if you wanted to look like that. For case 2, okay, we have instead, so we have v2, okay, which is equal to the initial velocity, which they gave us, plus gt. Okay, all of those are negatives. I'm putting everything positive by dividing everything by negative 4. From here, I see that t is equal to v2 minus v divided by g. And according to the height, right, it's exactly the same equation that for case 1. So h minus vt. Now this is, so the equation here for the displacement looks the same, but you do have a vt which we put to 0 for the case 1, but in this case stays because it's dropped with the initial velocity. And then minus 1/2 gt squared, right? So this I can write as 0 equal to h minus v times t, and t is v2 minus v over g, minus 1/2 g t squared. So v2 minus v over g squared. Okay, so let's keep playing with this. So this is 0 equal to h minus v2 over g plus, so from here I am multiplying those two, plus v squared over g minus 1/2 1 over 2g, v squared 2 plus v squared minus 2 v2, and then 0 equal to h minus, so let's finish it off, v2 over g plus v squared over g minus v squared 2 over 2g minus v squared over 2g, plus v2 over g by simplifying those two 2's. Okay, so this and this goes away, and now what do we have? V squared minus, so this is minus 2, so this one 0 equal to h. So we said 1 minus 1/2 is positive 1/2 v squared over g, and then this one is left alone, so minus v2 squared over 2g. Okay, so let's free the denominator here. Let's remove the denominator. So you have 0 equal to 2gh plus v squared minus v2 squared. Now let's start analyzing a little bit of stuff. So this 2gh reminds us of something, right? And this v also. So we're solving for v2 in this point, at this point, because v, we actually have it as a square root of 2gh. So 0 equal to 2gh plus square root of 2gh. So this is 2gh, right? Minus v2 squared. So from here I have 4gh equal to v2 squared. So this gives us a 2 square root of gh. Now, again, remember that v is equal to square root of, what did I say before? V is 2gh. 2gh is v, and v2 is 2 and then gh. So how are those two related? Okay, so basically you have to come up with the idea, with a way of saying, right, that so the expression according to the solution, so how are they expressed basically? You have always v2 equal to something, right? We are pointing already toward this one, but let's see if it is true, right? So v2 equal to this number. Now this one I can write as a square root of 2 and square root of gh. Okay, so how can I incorporate this? Do you see that you have a 4 in there? So do you see that square root of 2 times b is actually the same here? Because if I take square root of 2 multiplied by b, and remember that b, so square root of 2, b is square root of 2gh, right? This means I can just write 4gh, okay? So which is v2 squared, right? So those two expressions, so this is equal to this, is true because we just demonstrated it. We go back to that expression if you want this to be a demonstration for it, okay? So that would be your number 36. Then for number 37, you still have those balls that are dropped. Okay, so let's set a new paper. So 37, a ball is dropped from a height. So it's basically the same kind of scenario that you got to incorporate. Okay, from a height h, and initial velocity is 0. So this is the scenario that we are dealing with. So a ball is dropped from a height h. Okay, so initial velocity is 0, so this is just a drop. And this one instead is thrown from the ground with initial velocity. At what time the ball pass each other? That's actually kind of fun, because you just have to set up the system of equation and you're done. There's not much to think to some extent. So this ball is just dropped, right? This one instead is tossed it up and then it will come down. So when do they meet? Okay, so for the first scenario, right, you have it tossed by the height of h, so h is equal to, so actually 0, right, is equal to h, which is the initial position, and then v0t minus 1/2 gt squared, right? This is 0, so that would be the first equation. And this is for the first ball, right? This is ball 1. For ball 2 instead, we have a y equal to a final position equal to, actually, this is, let's now put it as a 0 because we want this to be the distance at which those two balls actually they meet, right? This is going down, this is going up. That would be an instant when they have the same height, which we define as h. This one is starting from h height, right? This is the h, and this is the 0 instead. So initial position 0. This is tossed with some kind of velocity t minus 1/2 gt squared, and this is for ball 2. Right, so they want to know at what time. So there would be a time where time and position are the same. So if you're looking for time, let's put those positions equal to each other. So h, h minus 1/2 gt squared is equal to v0t minus gt squared. Right, those go away. So t is equal to h over v0. Okay, So that's the one. And so E is your answer. And then 38. Number 38. They say a ball is dropped from the height again. How fast does the first ball move when they pass each other? And your answer is D, because V is equal to V0 minus GT, and this is the same as minus G. T we just found to be H divided by V0, and that's it. 39. For 39, you have just velocity as a function of time is given by V equal to alpha plus beta t squared, where alpha beta constant t is time. How far does the particle move during the first 3 seconds? Okay, so how far? So we need x. So x is going to be 1 up, so it's going to be the integral of alpha plus beta t squared in dt. So this means alpha t plus beta over 3t cubed, and x at time 3 is 3 alpha plus 9 beta. So the answer B. And the last question is velocity as a function of time is V equal to alpha plus beta t squared. Again, with constant, what is the acceleration? Well, acceleration is 1 down, so you have to take the derivative of this, so it's dv dt, which is 2 beta t at time 3 is going to be the 2 beta times 3, which is 6 beta, and we're done. See you tomorrow, school.